In this video, we'll talk about adding, subtracting, multiplying, and dividing integers, and a little bit about exponent notation. So first, we better know what integers are, so remind ourselves that integers are just the signed numbers, right? Positive and negative, whole numbers, and zero. When you're adding integers together, I think it's most helpful to just imagine going up or down a number line. If you're adding a positive, go up the number line, and if you're adding a negative, go down the number line, however many units it tells you to go. So if you have negative 11 plus negative 15, imagine that you're starting. Let's make sure we're a pen. Imagine that you're starting at negative 11, and then you'll be going negative 15, so down 15 units on the number line. So if you're starting at negative 11 going down 15 more units, of course you end at negative 26. There is no hard and fast rule that adding and subtracting with integers will give you always a positive or always a negative. It just depends on the sizes of the numbers. Here, if you have a negative 13, you're starting at negative 13 on the number line. Adding 4 means to go up 4 units, so you've ended at negative 9. If you're starting at 13 and you're adding a negative 6, it means like you're going negative 6 or down 6, so you're going to end at positive 7. So think about it as movement on the number line. Here are some examples for you to try. You might want to try them on your own. And then see the results here. I'm just going to go through the results. So if you start at 4 and go down 7 units on the number line, you end at negative 3. If you start at negative 4 and then you go down 7 units, you're at negative 11. So if you're not sure what I'm talking about when I say a number line, of course, I mean one of these. 0 is typically in the middle. Negative 1, negative 2, negative 3, negative 4 go out to the left, right? So negative 4 is over here on the number line. And if you're adding negative 7, it's like you're going further this way down the number line. So 7 units past 4 would be at negative 11. Negative 11 plus 8, so if you start at negative 11 on the number line and add 8, you're going up closer to 0, and so you'll land at negative 3. If you start at positive 8 and go negative 11, you'll be at negative 3. So those two results were exactly the same. And then the final one here, if you have negative 3 added to negative 3, very common mistake is to write 0 as the answer here. But in fact, if you're at negative 3 and you continue adding negative 3, you actually go further down into the negatives and you end up at negative 6. If you had negative 3 plus positive 3, that's going to put you at 0. Subtracting integers might be helpful here to think of it as adding the opposite. So anytime you see subtraction, right, if it's just two positive numbers, you could just subtract as you always have. But if there's anything confusing with negatives going on, you might want to think about the subtraction as addition of the opposite. Okay, let's see some examples so we can put it into action. Find each difference. So difference is the word that means the result of a subtraction problem. So here's an example. I'm going to keep the 17 the same, and I'm going to change the subtraction to addition of the opposite of negative 11, which is positive 11. So you can change minus a negative to the addition of a positive, and 17 plus 11 is just 28. Negative 18, we're going to keep the same first number, right? That's where we start on the number line, and we're going to change this to addition of positive 5, right? Adding the opposite. That's what subtraction means to do, to add the opposite. And then I can use my addition rules or my number line trick. If I'm starting at negative 18 and adding 5, I'm going up the number line and ending at negative 13. Here I have negative 18. I can think about this as just minus 5, as in I'm going down 5 on the number line. Or you can actually rewrite it as plus negative 5, because that is what addition of the opposite would look like. I find that step to be a little bit unnecessary when it's just straight subtraction like this, but it means the same thing, right? It means you're going further down into the negative side of the number line. So negative 18 minus 5, or plus a negative 5, is going to land us at negative 23. There's 3 more examples here. You can try them on your own. In the interest of time, I'm not going to go through them. Multiplying integers, so this does have a rule, right? If it's a positive times a negative, your result is going to be a negative. If it's a negative times a negative, the result is going to be positive. And if it's times 0, the result is going to be 0 no matter what. Here are some products for us to find. The first two are pretty straightforward. Product means the result of a multiplication problem. 4 times negative 7, the result will be negative 28. If they're both negative, the result will be positive 28. The last two examples are helpful because you have to think about what happens when you've got more than just two numbers being multiplied. If I go from left to right and I do negative 11 times 2 first, then this result will be negative 22. And then I'll multiply it by another negative, and the result will end up being positive. In this case, positive 44. So if you look across and there's an even number of negatives, the result is going to be positive. In the last example here, if you look across and you see there's an odd number of negatives because there are 3 negatives going on, the final result is going to end up being negative as well. The step-by-step approach to that is to say negative 3 times negative 3 is positive 9, and positive 9 times a negative 2 is going to end up being negative again, so negative 18. Exponential notation, so I'm sure you've seen exponents before. We have 4 to the 3rd power. That's how you might read that. 4 is called the base there. 3 is called the exponent. The whole expression could be called a power. It means to multiply the base number by itself. The number of times that you multiply it by itself is the number of the exponent. So that's how many times the factor of 4 would appear. Each of these 4s is called a factor in a multiplication problem, right? 4 times 4 times 4. These are 3 factors. Note down below, negative 5 to the 4th power and negative 5 to the 4th power are not the same. The difference being how they're written, okay? So if there is parentheses around your base number, that means the base itself is negative. So negative 5 times negative 5 times negative 5 times negative 5. Versus this one, there is not a parentheses around your base, and yet there's a negative sign in front. That means there is a single negative, and the base itself is just the 5, 5 being raised to the 4th power. And you would have to do all of the 5 times 5 times 5 times 5 first, take that result, and then make it negative, or stick the negative 1 in front of it and multiply by negative 1, however you like to think about it. So 5 times 5 is 25, times another 25 is going to be 625. So this one ends up being positive 625. This one ends up being negative 625. So you have to pay attention to the location of that minus sign. If it's in front with no parentheses, it means there's just one negative there. If it's in parentheses with the base number, then there are as many negatives as there are bases. So practicing that very concept, the first one here means that the negative 6 is being multiplied by another negative 6, giving us positive 36. This one means that there's a single negative in front, and 6 squared is 36. You want to do the exponent first, 6 squared, and then pop a negative in front of it. This one means that there's a negative 5 3 times, right? The base is actually negative, and so when we multiply that out, we'll actually keep that negative sign because there's an odd number of negatives. So negative 125 is the answer. Whereas this last one, the base is negative, but because there are 4 of them, the final result is going to be positive. 2 times 2 is 4. Another 2 times 2 is 4, and 4 times 4 is 16. And then there are a few more examples there for you to practice. Again, I won't in the interest of time. For dividing integers, rules are just the same as multiplication, right? If one's negative in the division problem, the answer is negative. If both are negative, the answer is positive. If it's 0 divided by a number, then the answer is 0. But the last one is new, and it's unique to division, that if you have a number divided by 0, you are to write undefined, okay? Negative 8 or any number divided by 0 is not a thing, okay? So we write that it is undefined. There is no value for it. It's not 0. It's not a 0 with an X through it or anything like that. It's simply the word undefined. It doesn't mean anything in math, so we write undefined. Quotient is the word for a division problem, or the answer to a division problem. So basic rules to practice here. Negative 12 divided by 4. If both are negative, your result will be positive. If the 0 is on top, it's a 0. If the 0 is on bottom, it's undefined. Yes, you should write the entire word undefined. Do not abbreviate it. If you're having a hard time remembering when it's okay to divide by 0, or when it's okay to have 0 in a division problem, I saw something cute once on the internet that said this. All right, this one is okay, meaning it does equal 0. That's a thing. This one is NO, not okay. Undefined, right? So NO and OK might help you remember when it's okay to have 0 in a division problem. And then a note about instructions, because this is how it might appear on a quiz or a test. If you see the instructions say perform the indicated operation, I don't want you to read that and think that it's something you were never taught before. What that means is rather than saying add, subtract, multiply, or divide, it's just going to say perform whatever operation is there. And so the operations in math are adding, subtracting, multiplying, and dividing. There are some other operations, square rooting, squaring things. But operations are basically the things that you do to numbers in math. So if the instructions just say perform the indicated operation, it means if it's addition, add them. If it's subtraction, subtract them. If it's multiplication, multiply them, and so on. So that's what that instruction means. And that's all.